Hello and welcome to another power electronics class. In the previous class, we finished buck and boost converters. Today, we're going to have a review session of the upcoming exam. Before I start with the review session, I just want to let you know that for exam number 1 is up to slide number 38. So the questions would be from buck and boost, but they would not include the buck boost converter. So it's going to be, again, up to slide number 38. So without further ado, let's start with the review class. Again, I will give you some questions. I will give you a few minutes to think on them and solve them. And the first student to solve them gets extra points on their upcoming assignments. And these questions are going to be 90-95% similar to what you're going to see on your exam. The only difference is going to be I may change, the numbers. Okay. So first question, in a buck converter, the input voltage is 15, output voltage is 10 volts. The switching frequency is 300 kilohertz. We assume we have an ideal switch. We want to calculate the pulse width, T on, of the switching signal, and the duty cycle D of the power pole. So again, T on and the duty ratio D. Sorry. Yes. Perfect. Yes. So we know that V out is equal to the duty ratio D times Vs. Therefore, D would be equal to V out or Vs. V out is 10, source voltage is 15. So this is going to be 2 over 3. In other words, it's equal to 6, 7, if we want to round it up. So the duty ratio is 67%, or 66.7% if we want to make it even more accurate. It's going to be 66.7%. Now, TS is 1 over Fs, so it's going to be 1 over 300,000 because it's 300 kilohertz. Gives us 3.33 microseconds. And as we know, T on is equal to dTs. So it's going to be 2/3 or 0.667 times 3.33 microsecond, which almost gives us 2.22 microseconds. Thank you, Tyler. Remind me to give you. Did you write it down? Can I go to the next question? Okay. Question number 2. In a buck DC to DC converter, an inductor with L of 20 microhenry is operating in steady state condition with the following parameters. The source voltage is 36 volts. Duty cycle is 0.2. Output power is 18 watts. Switching frequency is 500 kilohertz. Assume an ideal 500 kilohertz. Assume an ideal component, so no loss in the system. We want to calculate the output voltage, the output current, the inductor ripple current when the output power is 20 watts. Then we want to determine the new output current and the ripple current behavior if the output power is reduced to 10 watts with all other parameters unchanged. Does anyone have the answer? Mm-hmm. Mm-hmm. Yes, correct. Mm-hmm. Okay. And what is the minimal and maximum I? Did you get that as well, or no? Okay, but the rest was correct. Yeah, thank you. Perfect. Okay. So again, V out would be equal to D Vs. Duty ratio is 0.2. The source voltage is 36, so it gives us 7.2 volts. So this is the output voltage. Now, Ts would be equal to 1 over Fs, which is 1 over 500 kilohertz, 500,000, gives us 2 microseconds. Now, T on would be equal to dTs, which is 0.2 times 2 microsecond, gives us 0.4 microseconds. Now, the inductor's ripple, delta IL, would be Vs minus V out T on over L, which gives us 36 Vs minus V out, which is 7.2, times T on, which is 0.4 microseconds, divided by 20 microhenry. If we solve for this, we get 0.576 amps. So what is the delta IL? Delta IL is the ripple, meaning it's the difference between the maximum and the minimal current. So if this is I max and this is I min, delta IL is the difference between these two. Let me do it for the. So this is our delta IL. Okay. So if we find the average of the current, then I max would be the average current, or here average current is our I out, would be I out minus, or because we are doing maximum, so I out plus delta IL divided by 2. So this is delta IL divided by 2, and this part is also delta IL divided by 2. It's a symmetric, so half is over. And what is I min? It's going to be I out minus delta IL divided by 2. Is it clear? Yes. So I out, or I average, is at the middle of the ripple, delta IL is the total swing from maximum to minimum. Therefore, I max would be equal to I out plus delta IL divided by 2, because half of it is over this and the other half is under the average. And I min is I out minus delta IL over 2. Is it clear up to this point? Okay. Now, for case number 1, when the output power is equal to 20 watts. So I out would be equal to the output power divided by the output voltage. So 20 divided by 7.2 volts gives us 2.78 amps. The delta IL would remain the same. So 0.576 amps. This doesn't change again, which this is around 20% of I out. If we divide 0.57 by 2.78, it's around 20%. And this is just for you to visualize it. Now, the inductor current range, I min, minimal, would be this, the output current, which is 2.78, minus delta IL, which is 0.576 divided by 2. So this divided by 2 gives us 0.288, and therefore this would be 2.49. So the minimum current that we're going to get is 2.49. So if in the exam I ask you to find the minimal and the maximum current, this is the way you go. You first find the output voltage, you find the then you find the output current because you have the output power. Then you would calculate the ripple delta IL divided by 2, and then you would subtract that from the output current. You get the minimal current, and for the maximum current, you would have your output current, which is 2.78, plus half of the ripple current, which is 0.288. And this gives us 3.07 amps. So if I draw the ripple current, the average current is 2.78, or the output. Maximum current is 3.07, and the minimal current is 2.49. Did you write it down? Yes. Can I go to the next slide? Okay, now for case number 2, what was the output power? 10? Yes? Okay. So again, we have to find the output current. I out would be equal to, this time 10 divided by 7.2 gives us 1.39 amps. Since the output voltage and the input voltage and the duty ratio and the inductor has not changed, nothing has changed, therefore delta IL remains the same, which is 0.576. But this time, the ripple is 41% of I out. The last time it was 20%, now it's a bigger portion. Now again, if we want to find the range, I min would be equal to 1.39 minus half of the ripple current, which is 0.288, gives us 1.1 amps. And the maximum current would be 1.39 plus 0.288, which gives us 1.68 amps. So this time, if I want to draw it, the average current would be 1.39. The maximum current is 1.68. The minimum current is 1.1 amps. Can I go to the next question? Okay. So next question. Given Vn 12 volts, Vout 24 volts, Fs is 200 kilohertz, and Pout is 24 watts, we want to find In and D. First of all, can you tell me what type of converter this is? Is it a buck converter or a boost converter? Boost. Why? Because the output voltage is greater than the input voltage. Therefore, this is a boost converter. Yes, this is In and D. Want to find the input current, In, and we also want to find E. Well, let's do it like this because I think let's find I out, In, and D. So I out, In, and D. Yeah, I'm checking. I out and I in are correct, but D is not correct. What? For what? D. Okay. Let me go back a little bit. So for a boost converter, the equation is this: V out over V in is going to be equal to 1 over 1 minus D. So V out is over V in is 1 over 1 minus D, or I can write it like this as well. D is equal to 1 minus V in over V out. Therefore, D would be equal to 1 minus V in is 12, V out is 24, which we get 0.5 or 50%. Now the output current I out would be equal to the power P out over the output voltage V out, which gives us 24 over 24 gives us 1 amp. And IN would be equal to, again, P out. Why? Because this is an ideal situation and P out is equal to PN divided by VN, which again is 24 divided by 12 gives us 2 amps. So what does this tell us? This tells us that if you double the voltage, you're going to halve the current, okay? So if the output voltage is doubled, the output current would be half of the input. Why? Because we're not generating power in the system, okay? And it's an ideal situation, so there's no loss in the power. Therefore, when you double the voltage, you halve the current. It's the same as an AC transformer with no loss. Voltage goes up, current goes down. The voltage comes down, current goes up in the output. So always the output power and the input power are equal. Therefore, V out, I out would be equal to V in, I in. Can I go to the next question? Yes. Okay. So given Vn is 15, V out is 30, P out is 60 watts. Fs is 200 kilohertz and L is 22 microhenry. We want to find the ripple current delta IL. Again, if I go back to our equations. You can use this equation if you want to write it down. Vn dTs over L gives us delta IL. Did you write that down? Can I go to the question? Yes, okay. So again, delta IL is equal to Vn dTs over L, or Vn over L dTs. One point how much? Yes. You can also find the peak current for the inductor. Okay, we can also write this like this. This is also equal to Vn over L Fs, because Ts is 1 over Fs. Vn d over LFS. So what do we need to find? We have Vn, we have L, we have Fs, we don't have D. So first thing we need to find the duty ratio. So D would be equal to 1 minus Vn, which is 15, divided by V out, which is 30, gives us 0.5. So this would be Vn, which is 15 times 0.5 divided by L, which is 22 times 10 to the power of negative 6 times 200, which is our frequency, times 10 to the power of 3. And if we solve this, we get 7.5 over 4.4 gives us 1.7 amps. And this is 1.7 peak to peak, meaning it's the delta IL from here, the peak to peak. This is 1.7. Now, if you want to find the peak current of the inductor is in the input of a boost converter. So IN is 60, which is our power. Input and output are the same, over 15, which is input voltage, gives us 4 amps. Now the maximum peak inductor current would be 4 plus 1.7 divided by 2 gives us 4.85 amps. Now, the output current, if you want to find the diode current, is going to be 60 divided by the output voltage 30 gives us 2 amps. So the average current of the diode is 2 amps. This is the average current for the inductor. Again, why? Because in the boost converter, as you remember, the inductor is in the input and the diode is connected to the output. Inductor, and we have the diode. Now next, did you write this down? Can I go to the next question? So next question, given Vn is 12 volts, Vout is 24 volts, Pout is 48 amps, 48 watts, L is 22 microhenry, and F is 200 kilohertz. We want to find D, IO, IN average, and delta IL. Okay, do you have the, you want to have the answer? Perfect. Mm-hmm. Mm-hmm. Perfect. Great. Yes. So D would be 1 minus Vn over V out, which is equal to 1 minus 12 over 24 gives us 0.5. The output would be P over V, which is 48 over 24 gives us 2 watts. Sorry, 2 amps. Because it's an ideal situation, therefore Pn is equal to P out. So In, or the average I, would be equal to power again divided by its voltage gives us 4 amps. And finally, delta IL is equal to Vn d over LFS, which is 12. D is 0.5. L is 22. And Fs is 200 K. So if you solve this, you get 1.36 amps. Okay. Can I go to the next final question for today? Given Vs is 18 volts, V out is 9 volts, and Fs is 250 kilohertz, we want to find D and T on. So first you have to determine what type of converter this is. What type of converter is this? Buck, yes. So the equation is different from the previous one, the boost. The previous one was a boost converter. What is the answer? Perfect. D is for a buck converter, it's V out or Vs, which would be 0.5. And you can write it like this. That means 9 volts over 18 gives us 0.5. And what else? Oh, we wanted to find T on. So Ts is 1 over Fs. It's going to be 1 over 250K, 250,000, gives us 4 microseconds. Therefore, T on would be equal to dTs, which is going to be 0.5 times 4 microseconds, which gives us 2 microseconds. Okay. That's it for today's class. Just a couple of notes. Like 60% of your questions would be theoretical questions. So please read through the lecture notes, especially the introduction lecture notes. You're going to have a lot of questions about the applications of power electronics and the theoretical part. Like, for example, what type of switches do we have? How many different types of converters do we have? Applications of power electronics and solar system, photovoltaic systems, or wind, or something like that. Okay. Do you have any? Yes, I will provide you with all the equations that you need on the exam. For the online students, it's going to be different. I will send an announcement, but for okay. Any other questions? Thank you so much, and I will see you next week.